Welcome back to the channel, everybody. I'm Dino. It is New Year's Day 2024 today, and I've got a resolution, and my resolution is to become more proficient with electrical systems on motorcycles and power sports in general. It's been something I've been meaning to tackle for a while, and this series of videos is going to address just that. So why don't you sit back, grab yourself something warm to drink, and enjoy Dino's Tinker Shed. I have told you how much I really don't like electrical, right? I'll see you in a minute. So what are we going to talk about, and what is this series going to look like? Well, we are going to be discussing my 2009 Suzuki DR650. And the reason we're going to use that motorcycle is it's the motorcycle that I have. But even moreover than that, the Suzuki DR650 was designed in 1996. That's the most recent major change in the motorcycle. So the systems that it has are very basic and are pretty much within every new motorcycle that is sold today. Even though new motorcycles have additional systems within their electrical system in general, such as ABS, navigation, and all kinds of other bells and whistles that the DR650 just doesn't have. So I guess what I'm saying is, this series of video is going to be a very basic, rudimentary overview of the components that build all four electrical systems within the DR650. So what are these systems? Well, the DR650 has four systems, and those systems are the charging system, the starting system, the ignition system, and the lighting system. What I want to do is do one individual episode on each one of those four systems, and then also this opening video, which is going to be sort of a basic, what are the tools you're going to need, and basic overview on things like switches and relays and diodes. And I want to show you how to test those, because all of those make up the other four systems. So this is kind of the launching video for the 5-part series. And it's going to be a little bit in depth. I'm going to do my best to use footage that I have of each one of the components that make up each one of these systems. But in some cases it may be a little bit unreasonable to do so. I'm probably not going to pull my stator out to show you the stator, but I will show you some pictures of what stators look like, and I can show you where the connections for the stator are located on the motorcycle and how to test it in the frame so you can determine whether or not you need to change it. Okay, why don't we get started looking at the tools that you're probably going to want to have as you start a project like this. The first tool that we're going to talk about is this tool. I've mentioned many times about the importance of a shop manual anytime you're digging into a system on a motorcycle or a snowmobile. When it comes to electrical, it's almost essential to have one of these service manuals. This one is the Climber's Manual, and we're going to be using it, Chapter 9 specifically, to go through and trace out and test some of the systems on my DR650. None of them are giving me problems, but I thought we'll use this to sort of give you an idea of how to test things. Now, when it comes to electrical, a shop manual is going to tell you about a lot of things over and above just torque ratings for fasteners. It's going to let you know things like spark plug gaps, resistance for both primary and secondary coils on your ignition system, What is the resistance and testing sequences for things like your stator? And it's also going to show you things like how does the neutral safety switch, your side stand, and the starter relay all work together so that you can start your bike. Because sometimes you might think the starter's bad, and it might be the side stand switch. So it's really important to have a really good manual. But probably the number one thing that a manual gives you is a wiring diagram. And without a wiring diagram, you're basically shooting in the dark. And here's why. Here's the wiring diagram for my DR650, and the first thing I want to point out is the fact that it's laid out similar to the way the bike is. So here we have the headlight, the horn, the front turn signals, the speedometer. They're all grouped together the same way that the rear of the bike is grouped together here with the rear turn signals, etc. And they try to do the same thing by sort of orienting things in similar locations on the diagram as you might find them on the bike. So here's the right hand handlebars, and over here are the left hand handlebars, and you can see the switches and things are laid out very clearly. Here's the fuse panel, and the dotted line around that fuse panel means they're within a container, a box or whatnot. And that carries on down through the entire wiring diagram. As you can see, Climbers really does a good job of color coding the manual, and what you need to understand is all of the different colors of wire here correspond with the Suzuki itself. They match up exactly with what's on the bike. So this one here that's orange with a yellow stripe, or the next one which is black, or white with a black stripe, or green, whatever they are, match up to the same color wires on your bike. And this is why it's important to have the right year picked out. The good thing is you can use all of this information to check different wires and see what's fed by what wire without ever having to get into the bike. So it really is handy. Now let's take a look up in the upper right hand corner here where the diagram key is. Your diagram key is going to define what the icons on the left side here represent. So for instance, the first icons here are connectors. These are disconnectable connectors within the wiring system. You're going to see that they can be either a single wire or a double wire, or in a lot of cases a multi-wire connector. The diagram itself won't show you what type of connector those are, but it will tell you how many wires enter the connector, how many exit the connector, and more importantly, it will tell you what color the wires are entering it and what color they are exiting it, because at times the wires may change color depending on what side of the connectors those actually are. So you need to pay attention to that. Next, you're going to see these two connectors here, which are your grounds. Now, the main frame ground comes off of the battery with a heavy wire and it's bolted to the frame. All of the grounds that are just a simple ground would be things like your starter. Your starter is fed with a hot wire from the positive side of the battery, but the housing of the starter is bolted directly to the engine, and that creates the ground circuit because your engine is grounded to the frame. So power would flow from the battery to the positive terminal on the starter, through the starter, out the battery, and down back to the frame ground. Next, you're going to see connection. So no connection or connection. What these represent is the small black dot on the connection icon means that those wires are physically connected, usually soldered and taped or shrink wrapped shut, allowing electrons to flow in either direction from the connection point. Where the wire is lacking that center dot, what that means is there is no physical connection. So those wires are simply in proximity. They may cross over one another, but physically they're not connected in any way. Last, it's going to show you where there is a diode. Now, diodes, for those that may not know, control the flow of electrons in a direction. So in this case, the arrow is pointing to the left, meaning that electrons can flow from right to left, but if they try to flow backwards, they're going to be stopped by the diode. Diodes are used in things like your turn signal relay. So this will show you and identify where that diode is. On top of the diagram key, we can learn a few more things from the wiring diagram itself by looking at different components. The first thing that you need to understand, at least the way I understand it myself, is that when you look at a wiring diagram like this, it is a snapshot of time when the motorcycle is at rest, or the vehicle or the piece of equipment is at rest. So the ignition system is turned off, and this is the way all of the switches and relays sit in a natural state. With that in mind, we can take a look maybe up in the corner here at these 3 switches and the ignition switch and learn a few things from them. The first is, if we look at the engine stop switch and the starter switch, their symbol is slightly different than the front brake switch. They have this raised T on the top of them, which in the DR650's case indicates that's a push button. So the front brake switch is a micro switch that's connected to the front brake lever. In all 3 cases, though, we can see by the diagram that all 3 switches are in a normally open position, meaning that when they sit naturally, current does not flow through the switch. So basically it's like the lights are off, essentially. And it's only when we push the starter switch in or we grab the front brake lever that current is allowed to flow through the switch and in turn provide power to whatever load it has, whether it's the starter or your brake light at the back. So when you look at these, you can right away tell how to test that switch. If it is a normally open switch, such as the case with the starter switch, if you test that for continuity, in its normal state, you won't get any continuity. There should be an open circuit. However, when you push that switch in, you should right away get conductivity, see some ohms on your meter, or hear the audible tone, so you can tell whether or not that switch is in good condition. The ignition switch is interesting because it shows you which wires are paired together. So if you were to look at the ignition switch in the on line there, you can see the black dots that are connected with a line. When you turn the ignition on, there will be continuity between the wires that are in line with those dots. So for instance, the first pair, the red and the orange wire, should have conductivity between those when the ignition is turned on. At least that's how I understand it. If we carry on down the line, the orange with the yellow stripe and the black with the white stripe should also have conductivity when you separate the connector and use your probes on the ignition switch side of that connector. So this is how you can test these in the bike without actually having to take the switch out. And the wiring diagram is the key to knowing where your continuity and where your power comes from. So it may look like a big jumbled mess here, but you can really learn a lot just by sitting and studying this wiring diagram before you even go out and start working on your vehicle. The next tool is a reliable multimeter. And I say reliable, not high quality multimeter. I've tested this Zoyo that I bought 2 or 3 years ago right alongside a Klein and a Fluke, and it does exactly the same job. It's dead on accurate, and it cost me, I think, $34. But there are a couple things with a multimeter that you really need to ensure you have while you're testing like this. The first is it obviously needs to test 20 volt DC power. This one does, it does AC and DC. It needs to check ohms for resistance. So you can check things like your stator, your coil packs, things like that. And this one also has a 10 amp fused circuit. So you can use it in line of a circuit and look for parasitic draw up to 10 amps without damaging the machine. The other nice thing that this has is it has an audible continuity tester. Some of them don't have them, this one does. Now you can test continuity with your ohms, but it is nice to have that audible tone when you can't see the screen. You can touch two ends of a wire together and it's gonna tell you audibly that you do have continuity. So a good quality or a how did I word it? A good functioning multimeter is essential. In conjunction with your multimeter, you really are going to want to buy yourself a test light. These aren't terribly expensive. You can get a basic test light for under $20. And what these are used for is locating power within the circuitry of your motorcycle or car. Now, every time you grab this out of your toolbox, you really should test it. So you take the clamp here and hook it onto the negative side of your battery. And then you touch the pointy end to the positive side and the light inside the tool should light up. This means you have power flowing through the tool. Now the way this works is after you've connected your negative side to the battery, you can go through and look for power where it should be according to the wiring diagram. If you have a connector opened up that's supposed to have power when you touch the probe to it and it doesn't light up, you have a problem and you need to dig a little bit deeper. So a nice test light is something you really need to have alongside that multimeter. They complement each other and it should really be in your electrical toolbox. Next, I would have a few alligator jumper cables here so you can jump switches and rule those out of your testing. And here I have one with a fuse holder built in so that if you're jumping something that you're worried about, this you can put a small fuse in it. This one has, I think, a 10 amp, which is actually pretty heavy, and protect the circuit itself. There are a few other things that I would have on hand as you dig into the DR650. One of them is this. And what this is an induction tachometer. So you wrap this wire 4 or 5 times around one of the 2 spark plug leads, and then it will tell you what the RPM of the engine is. You don't need this a lot. I use it when I'm setting my idle, but there are some tests where you want to see the output, the charging system, things like that, where the manual will give you a specific RPM that the engine needs to run at, and then you'll get a specific voltage coming out of the charging system. So these are relatively inexpensive. They're probably $10 or $12 on Amazon, but they're very useful, and you can set them up for single or multi-cylinder engines, and they work with 2 strokes and they work with 4 strokes. So it's a nice little tool to have that's inexpensive, and you can move from vehicle to vehicle. I would also suggest purchasing one of these, which is a spark plug tester. You can pull the spark plug out of the system, hold it against the cylinder head, and then cycle the engine over to look for spark. But this saves you some time and is a little more visible. This goes in series, in line with your high tension lead, and it has a bulb in there that lights up to show you if you're getting spark in that particular cylinder and whether or not the spark plug is working or fouled. And there's one other tool that I'm going to use today that you don't need, but I'm sort of becoming fond of as I work through this system, and I'll show you what that is now. That tool is this tool here, which is the Electrical Circuit Tester Brilliant Tool for the Auto Electrician and Mechanic. That's a mouthful. What this is a knockoff version of a Power Probe 1, the original Power Probe. And this is made in China, and these are now, I believe, under $20. My friend Marcus swears by Power Probes. Now they're up to, I think, Power Probe 4, which has built-in multimeters that does a lot of other functions. But this simple device here allows you to look for both grounds and hot wires. It allows you to look for dead shorts, and it gives you the ability to power equipment within the vehicle that you're looking at. So you can power lights, blower motors, all kinds of things using this rocker switch here on the device. Now, again, I paid less than $20 for this. It hooks up both the positive and negative leads to the battery and gives you the ability to look for different things. So I'll probably be using this throughout the series. It's not something you need to buy, but as I use it, I'm finding it's quite a valuable tool for a lot of reasons. That really is about the majority of electrical testing tools that I have. I do have a couple extra things in the drawer there that I don't use all that often. So for about $50 to maybe $75 Canadian, you can have just about everything you need to do the basics on a bike like the DR650. And maybe what we'll do now is we'll use these tools to sort of show you how they work and test a couple different things to show you how you use these tools in the real world. I'm not going to use it on the bike today just because we're going to be doing that in the future. But maybe what we'll do is I'll show you how to use a multimeter here to test a 5-pin automotive relay, and maybe we'll start with fuses. I want to talk a little bit about fuses and how you test them with both a multimeter and how you can test them with a test light. So let's start that right now. If you're having problems in a circuit and the wiring diagram says that that circuit is fused, then the first place I'm going to check is that fuse itself to make sure it's clean and to make sure that it's functioning. The role of any fuse is to provide overload protection. So amperage is rated for each one of these differently. Usually the color corresponds to the amperage. This is a micro blade fuse and it has a 0.5 amp rating. This blade fuse here, standard blade fuse, I think is a 5 amp. And this red maxi fuse is a 50 amp. Now next to these is an old style glass fuse, and this is an auto resetting breaker, a 20 amp auto resetting breaker. So this is like a fuse, only it will reset itself if you draw too much amperage. How do you know if a fuse is good or bad though? Well, the easiest way is to pull the fuse out and look at it. Oftentimes when you've overloaded a fuse and it's blown, you're going to see it in the plastic casing itself. It's either going to turn black, you're going to see a break in the wire, you're going to physically know and see that that fuse is not any good. But that's not always the case. In fact, I've had fuses that look exactly like a brand new fuse that just don't work. Now there's a couple ways to do this. If you have the fuse out of the motorcycle or car already, you can use your continuity tester to simply touch each side of the blade on the fuse. If you hear that audible tone or you see resistance, you know the fuse is good. But if it's already in the motorcycle, you really can test it in the bike. The way you do this is on the top of the fuses, especially the mini and the standard blade fuses, there are two metal points that you can probe with your test light. Now, some people will tell you that you can use your continuity tester on those 2 points with the blade fuse still in the vehicle. And it does work sometimes, but there's some caveats here. One is, if you've got the power on your vehicle, or there's power flowing through that circuit with the ignition off, you run the risk of damaging your equipment. The other thing is, even if you don't damage the equipment, you might be getting false readings through feedback through circuits that maybe aren't wired correctly. The right way to test it is to take your test light and hook that cable up to the negative side of the battery once again. Now, there are 3 conditions that fuse will be in. Now, on this example here, I've got a small fuse panel, and Carl's hands are the ones making the tests here, and you're going to see that he tests his test light on the positive post, so we know that's positive, and then he goes up the center of the fuse box, lighting up each fuse to know that there's power on the bus itself, the hot side bus. Next, he goes around and tests the opposite side of the fuse. Now, if those fuses have power with the ignition off, the test light should light up on both sides of the fuse, as you're seeing here. If, however, the fuse is blown, he's only going to get power on one side of the fuse, the positive bus side of the fuse. The other side will be cold, it'll be dead. Now, there is also the time where there is no power on either side of the fuse. And what that usually is it's keyed power, meaning you need to turn the ignition system onto the vehicle so that you get power to the bus side, the positive side of the fuse. Then the test is the same. Either you have power on both sides of the fuse, or you only have power on one side of the fuse, indicating the fuse is bad. So on the DR650, where there's only 3 fuses, really you can just pull it out, look at it, or test it with your continuity tester. But if you're looking at this video and you've got a motorcycle or car with a multitude of fuses, the test light is your best friend for checking fuses in place. Another component you're gonna want to know how to test, and the DR650 does have, is this. Now, this is a 5-pin relay, and they do come in 4-pin. I think there's even more variety of this out on the market, but for this case we're going to look at the most common, which is a 5-pin relay. If you're not sure what a relay is, well, a relay basically is an electric switch, and these are used when you have a very high load on something, say like fog lights on a Jeep or heated grips on your bike, and you don't want to run heavy wire up to the switch on the handlebars. What this does is it allows you to run thin wire on a low amperage circuit to one side of the relay. When you turn that handlebar switch on, it activates an electromagnet inside that relay, closing a much heavier duty switch that allows power to flow from the battery or the fuse panel to the heavy load that you want to power up. This means that you have large wires that aren't going all the way up to the handlebars. You're not melting thin wires trying to power too much load, and it makes things much safer and much cleaner overall. The challenge with a relay is they tend to either be working or not working. And sometimes when they're not working, they give symptoms to sort of say that they should be working. And what I mean by that is, when you apply current to the low side of one of these relays, a couple things happen. One is they make a clicking noise, an audible clicking noise. That's the electromagnet closing the load side of the circuit. And you can feel that as well if you touch it. So both of those are indicators that that relay is working properly. In fact, if you suspect the relay, the first thing you want to do is apply power to it, listen for that click, grab a hold of it, and feel if you can feel the switch moving. Especially if it's in a place where there's multiple relays or it's kind of noisy, holding it or putting your fingers on it will let you feel if that particular solenoid is working, or relay is working. However, even though it may sound like it's working and feel like it's working, sometimes they ain't working. And you need to pull these out and put them up on a bench. To remove one of these, you just grab a hold of the connector that fits down below and pull them straight out. This is a generic 5-pin relay. The DR650 uses a 3-pin relay, I believe, on the starter circuit. And when we get to the starting system, we're going to test that specifically. In this case, I'm going to show you how to test a regular old 5-pin relay here for resistance. So there are, on a regular 5-pin relay like this, we have your normally closed circuits. These are the ones here that would trigger, these are your low powered circuits that would trigger power to come across these 2 points here. We want to test the resistance between these 2 points to see what it is. To do that, we're going to use our multimeter. On this 5-pin, we're going to take a battery and we're going to apply power between these 2 points here, which are normally closed circuits. There's a pathway between these two. When we do that, we are going to apply power in there. The electromagnet is going to close the switch between these 2 poles here. And that is going to give us continuity that we can read with our multimeter. And I'll show you that right now. On this 5-pin relay, we are also going to test resistance between the 2 normally closed posts here. So to do that, we are going to take our multimeter, I'm going to switch it over to ohms, and if yours is not auto ranging like mine, you're going to want to set it to your lowest setting, probably 0 to 200. Next, you're going to take your probes, and it doesn't really matter which side you're going on here. We're going to probe these 2 posts, the normally closed posts, to see what the resistance is. In this case, it's around 68.5 ohms. For a 5-pin relay like this, you want to see that resistance somewhere between 50 and I think it's 200 ohms. Any less or any more than that, and you've probably got some issues between these 2 normally closed posts, and the relay's probably not functioning totally correctly. And this is where you can run into problems where the circuit may close, but it may not hold that connection, and the relay's probably junk. Well, it is blowing and snowing out there, just in time for me to wrap up today's video. I really hope that you enjoyed it. Again, today's video is a very basic, rudimentary understanding of the DR650 and an introduction into this 5-part series that I plan on doing. And I just want to remind everyone out there, I am not an expert at this. I am not a mechanic or an electrician of any kind. And this is part of my own learning that I want to share with you, and I hope that you enjoy it. If there are some things that I'm missing there or I'm getting incorrect, please, please, please include them down in the comments below for other people to see so that I can learn and others can benefit from your experience. As I said, I'm planning 4 more episodes after this, and they may take a week or 2 to get these ones in the queue just because they take a bit of time to do the shots and explain things. Do be patient with me. I'll probably interlace those with a couple shorter videos on the weekends just to sort of see what I'm doing around the shop, what's going on. And I'm hoping with this snow arriving, I might be able to make a couple snowmobile trips, which might impact my upload schedule as well. So please be patient with me. If you like it, please, by all means, feel free to subscribe, like the channel, and share it. I love to watch those subscriptions go up, and I do appreciate all the support everyone has given me throughout 2023. And 2024 is looking fantastic. So until next time, please be safe, have fun, but most of all, tinker easy. I'll see you soon. Bye for now.